In this example, I want to graph y equals negative sine of 2 times the quantity x minus pi over 4 plus 1. And I always try to figure out the key features of the graph first. The amplitude here, notice that this has been flipped upside down. It's been reflected over the midline, if you want to think about it that way. However, the midline is, the amplitude is still going to be positive 1. We just have to remember that the graph is going to go down first instead of up first. The midline, we're adding 1 at the end, so that's going to shift the graph up 1. That's going to be y equals positive 1. Okay. The phase shift here, we have a phase shift in this. This is going to be shifted pi over 4 to the right. You can say that the phase shift is just pi over 4. I like to specify a direction. I just think it makes things more clear. The period here, if you notice you have this multiplier here, and make sure that needs to be factored out of parentheses. If it's not outside of parentheses, if it's been distributed into here, it's actually going to affect this and you'll end up with the wrong phase shift. So make sure it's factored out in front. You're technically taking the sine of this whole thing if you were to type this into a graphing calculator. So do make sure that, but typically in textbooks they don't put those parentheses there. It's kind of assumed. Anyway, the normal period would be 360 degrees over 2 pi if you're working in radians. In this case, this graph is moving 2 times as quickly, so that means the period is going to be half as big, 180 degrees, or if we divide 2 pi by 2, we get pi radians. So that's kind of an important feature. All right, I always start out with the midline. The midline is at 1, so I'm going to draw that in on my graph here. I think I'm going to make that 1, that 2, and 3. Okay, so my midline is going to be at 1, and I always draw that in early. And again, it's not really part of your graph, so you can just kind of dot it. All right, so there's my midline. Now, the intersection points are going to be a little bit more challenging. I always think back to what the original sine or cosine graph looks like. Sine crosses the midline at 0, pi, and 2 pi, okay? So instead of crossing at 0, pi, and 2 pi, there are 2 things we have to consider. First of all, we've got to condense it down and we've got to get the correct compression to get the right period. Okay, so we can divide everything by that multiplier of 2, okay? And if it crossed at 0, pi over 2, and pi, it would have the correct period. However, there's a twist here. There's also a phase shift. It's been shifted pi over 4, or remember that's 1/4 pi, to the right. I need to apply that 1/4 pi to each of these values, shift them over. So that 0 is going to get shifted over to pi over 4. This is 1/2 pi, which is 2/4 pi if you want to deal in fourths. 2/4 plus 1/4 is 3/4 pi, or we write that as 3 pi over 4. This would be 4 pi over 4. We're adding 1/4 to 4/4, and that'll give us 5/4 or 5 pi over 4. Okay, so 2 things have to happen here. You divide by whatever that b multiplier is out there in front of parentheses, and then you add or subtract your phase shift, and that'll give you the correct intersection points. Okay, now you'll notice it's 1/4 pi, 3/4 pi, and 5/4 pi. So I did, when I set up my graph, I set it up in fourths, and that'll make things a little bit easier. So 1/4 pi, pi over 4, I'm actually going to write pi over 4 in here. Pi over 4 is going to be that point right there. 3 pi over 4, so this is 1/4, 2/4, 3/4. 3/4 pi would be right here, so 3 pi over 4 is right here, and that point's going to go in there. Okay, and then we add, the next one's going to be at 5/4 pi, so that'd be 4/4, or 1, and then 5/4 is going to be that next position there, 5 pi over 4, and we can put in our point right there. Okay, now 2 things. This graph is going to be upside down. It's got a negative out in front, so the graph is going to go down first. The amplitude's only 1, okay? So it's going to go down an amplitude of 1 from that starting point. And it's going to go up an amplitude of 1. And the graph will kind of look like that. And again, you may want to put a couple more intersection points here as you go farther out, just to kind of continue the pattern. I think it's kind of advisable to try to do that. And so you can see some of those other values here. So anyway, the main part of the graph, it went down first, then it goes up, and again, it's going to kind of continue like this. And again, you may want to take it back a few units here as well and kind of show that this pattern is going to continue in that direction. And so that's how you would make the graph of y equals negative sine of 2 times the quantity x minus pi over 4 plus 1.